Okay, so today we're going to look at other ways of displaying our data. This is always data when you're looking at one list or one sort of variable. You might be looking at, it might double up sometimes because you might have you compare them. So say you might have female heights and male heights. So you do the same type of graph and compare it. So maybe a back-to-back stem and leaf plot or something like that. But it's generally, we call it univariate. It's just looking at the one list of data. So there's what that says there. So we're going to use a stem and leaf, but sometimes a stem and leaf can be good for using two sets of categories that are the same. So that's what I said. Maybe if I took my class results, say I've got 2 Year 12 furthers, and I might put them in a back-to-back stem and leaf plot, their SAC scores, and then I'll be able to see how it compares. Okay, so the advantage of a stem and leaf plot is that it does graphically display the data, but it still has the actual the original values there, so it can be quite good. So if we have a look at down here, this stem and leaf, the key is vital. So you've got to have a key, and you need to read the key, so that you be really careful in a multi-choice. You've got to be careful. So this key is saying that the stem is like the tens and the leaf is the units. So say for that is a number 16. But sometimes if I change the key, say I said the key was, and I wrote, I don't know, like that, and I said that equals 2.4, well then say for example that one would be 5.3. So can you see it's vital that you read what the key is. So we might say that equals 2.4. So yeah, does that make sense? Be careful at reading the key. I've seen that's just been a little doozy sometimes. So it's not very good for displaying big amounts of data because it would look too crazy. So it's generally with if you've got a list of values, maybe like 50 or less is what they're saying there. All right, so let's just go. They're very easy. So just to do an example question, the stem and leaf plot below shows the distribution of mathematic test scores for the class of 23 students. So N23 is important because in case they ask us for the median as well. So for this class, the range of test scores is, so range is, we will do more of this later on, but just so we can do it now, is maximum minus minimum. So if I go and read off this key, now the key says it's 42 like that, so the minimum is here, which is 40, and the maximum is this one, so it's 40, oh sorry, the other way around, 89 minus 40, which would then be 49. So that's pretty easy. Okay, now for the class, the interquartile range is, we're going to learn this a little bit later, but I might just do it now here because we've got a stem and leaf plot, and we'll do it again later. So the interquartile range is actually the Q3, which means the third quarter mark, minus the Q2. The Q1. God, I'm going crazy today. So minus Q1. Sorry. So what you can do, so if you remember when we have our data, so we have, say, our 23 students of data, if we split it in half, that would be the median. Yeah? If you split the first half in half, that would be the Q1. If I split the second half in half, that would be the Q3. Does that make sense? So if I've got 23 pieces of data, so say roughly you would say that the halfway mark of the median is going to be at the 12th spot, isn't it? Yeah? So remember, the median will be at the 12th spot for 23. So what I'm saying is, remember, the median can be found at n plus 1 divided by 2 position. So what I did there was say 23 plus 1 over 2, which is 24, so the 12th. So if I go find the median, so I'm going to count along 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's the median. This one is the median. So now if I've got 11 numbers underneath it, what would be the middle number of 11? Do you know? So Q1, it would be like the 6th. Can you see that? You'd have 5 above it, 5 below it. So if I count along 1, 2, 3, 4, 5, I reckon that's Q1. And see how I've got 1, 2, 3, 4, 5. See how I've got 5 above it too? So it would be the middle of that bottom thing. So I'll do that again, but I'm going to go backwards. So I'm going to go 1, 2, 3, 4, 5. So I think that is Q. I think this one's Q1 and I think that's Q3. So if I do that, I'm going to say it's 75 minus 57. So what would that be? That would be, so 18, that would be that, yeah? So that's how you can do it. The other thing is you could have put all these lists in to list and spreadsheets and found it with that statistics that we showed the other day. That actually takes longer than what we did. Once you get quick at what I did then, I explained it to you. Once you get quick at that, that's probably a quicker option than entering a whole list. Especially time is poor. So that's where you gain some knowing how to do that against a person who's going to rely on the calculator to put that all in. These are things that you would look at in an exam of what is it worth me putting the list in. Maybe there's a few more questions on this and you go, all right, I'm going to do it. I'm going to put the list in and it's going to save me time. With this one, it's pretty easy to do. There was only questions 4 and 5. I would have looked at it and the range and interquartile. I think I would have gone this way and moved on. Okay, so we've got a couple more questions here. So the back-to-back stem and leaf plot displays the wingspan in millimetres of 32 moths and their place of capture, whether they were in the forest or the grassland. Which variable, wingspan or place of capture, is categorical data? You guys tell me, which one? Wingspan or place of capture? So that's the categorical, isn't it? Place of capture, good. Write down the wingspan in millimetres of the, write down, didn't even read that right. The modal wingspan in millimetres of the ones in the forest. So if I go to the forest ones, what's the most common one? What one can you see a lot of? Yeah, it looks like 20, doesn't it? So that's right. So you write, it said 20 millimetres. Okay. The biggest, just to remind you, the biggest mistakes I've seen in these ones, just people reading the wrong side. Especially when this one sounds very different, forest, grassland. Sometimes they had like actual temperature and predicted temperature. They sound very similar. There's one that they sound similar and you accidentally pick the wrong thing. All right, it says use this information in the back-to-back stem plot to complete the table below. So can you see here we are missing Q3 of grassland. So if I go up to grassland and just to go over like what we did before, there's 19. So what would the median would occur where? Occur at the 10th. Good, you're getting used to that. You did 19 plus 1, 20, yep. So if I go along and find the median, so I'm just going to go, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I say that is the median. So the halfway mark of the bottom or the first half, if you've got 10, what would it be? If I did the 5th, wouldn't I have 4 above it and 4 below it? Are you happy with that? So if I go 1, 2, 3, 4, and I think that's Q1, 1. Oh yeah, well what am I doing? I need to do Q3, sorry. But see how I'd have 1, 2, 3, 4? See how that pattern works? So I'll do it down at the Q3, sorry. I'm going to go backwards. 1, 2, 3, 4. So I think that one is the Q3, which is, what number is that? 30, 36. And then when I have a look down here, it doesn't seem unreasonable, does it? 36, it's come in after the median, so that looks okay. Okay, the back-to-back stem plot suggests that the wingspan is associated for place of capture. Explain why, quoting appropriate stats. So this is where you need to look at. So what I'm going to do, they reckon it's associated. So I've looked down here. Go for the median first. It's easy to compare the median. So if I go here, can you see forest is 21 and grassland is 30. So explain why the values using appropriate statistic. So you just can say the wingspan, the wingspan is associated, so the wingspan could be suggested that it's associated, whatever, blah, 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 because the median wingspan, I'm going to shorten this, for forest was 21 millimeters compared to grassland, which was higher, yeah, with 30 millimeters. So I'd say, yeah, so you just write a little thing. It can be suggest that it's associated because the median wingspan for the forest is 21 millimeters compared to the grassland, which was higher with 30 millimeters. That's all you have to write. See how I don't say why? That's something for the biologist to work out. Yeah? I'm just stating, yeah, the data does show us that where these, what are these birds are captured, it's making a difference on what their wingspan was. Okay, now down here, I thought I did this, sorry, should have showed you. Here is the examiner's report response. So if you've got one of these, you've got it in your notes now. It says the medians differ from the forest to grassland. Now, we need to make note. See, full marks were awarded to students who described the change in median values and quoted these medians for both places. Can you see that? Now, I did that, didn't I? I quoted both of them. The mean is not part of the STEM plot 5-number summary and was not appropriate to use because the outlier. So see how, remember I said the mean's not a resistance statistic, so it'll get affected, so you wouldn't use it. And students who initially gave the required median comparison and then went further by quoting comparisons of other irrelevant statistics were not awarded full marks. So don't worry, go with what's obvious, and that's it. Especially because it's 2 marks. That's what they want, the quote of the median of what's differ and the actual values. There's your 2 marks, okay? All right, so the table shows the day number and minimum temperature in degrees Celsius for 15 consecutive days in May. Which of the 2 variables in the data is the ordinal variable? So ordinal, remember, is a categorical data, but it has some order. So out of these 2, which one's ordinal? Good. So day number. So see how it has a numerical sounding name, but it is actually categorical, isn't it? Yep, good. The incomplete stem and leaf plot has been constructed using the data values for days 1 to 10. So remember, you're only using these values. Complete the stem and leaf plot by adding the values, so we've got to finish it, 11 to 15. All right, so we need to go add these in. So 11 was 7.5, so I'd put up here 5, is that correct? Now, be careful, this stem and leaf plot has to be in order. So although I did 5, I'm lucky because this 7.7 is actually larger than 7.5, so I'll put that one in and I'll cross that out. Now 8.0, so I'll put an O. I've got 8.6, so I'll put a 6. And 9.8, so an 8. And there you go. I'll finish that off. Okay, so here's an ordered stem plot. I don't know why they say ordered, they're always ordered. Shows the maximum temperature in degrees for the same 15 days. Use this stem and leaf plot to find the value of Q1. So let's go and have a practice again. Now they said N is 15 days. So let's think about it. Where would my median occur? On the 8th. Median occur at 8th. All right, I'll go find that. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's the 8th. So what do we want? Q1. So if I've got 7, what would the halfway mark be for Q1? 3? Really? See, because you go 1, 2, 3. Circle that. And have I still got 3 above it? 1, 2, 3. Good. So what number is that? Make sure you read the key. 12.2. Good. So we can write 12.2. Now here again, just be careful. The percentage of days with maximum temperature higher. So percentage, remember what I said, if you always write this. So we want the amount over the total times 100. Generally finding what's the total of all these days. Yep. How many of all the days were there? 15. And higher than 15.3, was it this one? 1, 2, 3. So there's 3 higher times 100%. And what's that equal? 20%. Okay, dot plots are very easy to do. Your calculator shoves them up straight away when you go to select a graph. But you wouldn't use a dot plot on a massive amount of data. You shouldn't really. It's not a very good representative. So only for small amounts of data. I've done one here that we can practice on. So what you would do, you make sure you have a ruled number line. And I don't know what my lowest one, I think it's 21. So you just have 21, 22, 23, 24. And you rule this up. I don't know what I go up to. 28, 29, sorry, 30. And all you simply do is put a dot above it. So I've got a 22 there, there's a dot. A 29, a dot there, 27, whatever, 23. This one was not, I don't know where I got this data set, but it's not a very good one to show, but anyway. 21, 23, 24, and 30. Okay, so you can do it. So here I showed you down the bottom how you could shove it in a list. You probably do that quickly because it'll accurately give you, it's not a big list, so to shove it in the calculator won't take too long, and it is you can show you all the data points. If you've got to do one in a sack, make sure it's a rule. We would be looking for a ruled, evened out number line underneath and the dots and things like that. And also labelled. What is this we're talking about? All right, let's go a few exam questions to see how a dot plot comes about. The dot plot below displays the difference in travel time between morning peak and evening peak travel times for the same journey on 25 days. The percentage of days where there was 5-minute difference in the travel time between morning and evening peak times is. So there's a 5-minute difference. Now, they've gone, you would have to look at, a 5-minute difference could be both ways, yeah? Worse off or better off, couldn't it? Yeah? So they're sort of asking a 5-minute difference. So I might count those ones as well. Oh, that one's 6 anyway, so that's okay. So this one down here, I was worried about, but it's more than 5, so we're not going to worry. Okay, so 1, 2, 3, 4, 5, and what did they say? The percentage. So remember, we've got to do, for percentage, the amount out of the total times 100. So I just did the amount, which I said was 5 out of 25 times 100. Nice, another easy number. What's that? That's a quarter. No, that's a fifth. even, so another 20%er. And the median difference in travel time is, so if you've got 25 dots, what would the median occur at? Good, median at 13th. So they're in order from lowest to highest on a dot point. So we can just do that and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what number is that? 5, 4, I think it's 3. Okay. And that's how that one. Okay, so the dot plot below shows the distribution of daily rainfall in millimetres at a weather station for 30 days in September. Write down the range. So the range is max minus minimum. So the range includes outliers, so it doesn't matter, whatever's the biggest, which is 18 and 0, yeah? So we've got 18 minus 0, so the range is 18. What's the median? They told me what n was somewhere up here, yeah? 30 days, so n equals 30, so where will my median occur? So 15.5, yeah? 15 and a half, I don't know, what do you say that, spot, whatever. So let's go count them. Oh my God, 1, 2, 3, oh my God, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it's happening in there anyway. It's not it was in there, so what was that? 0, yeah. Circle the data point on the dot plot above that is the third quartile. So just to make it a little easier, third quartile, if I think when I split 30 in half, I get 15 and 15. If I split that in half, could I do like 7, wouldn't it be the 8th? 7 above, 7 below, yeah? So I'll do it like that. So they want Q3, so I'm going to go backwards. I'm going to go backwards 7. 1, 2, 3, 4, 5, 6, 7, and it's the 8th one, which, oh, sorry. You got to circle it, that one there. So you just had to circle it. That would be another one of those questions where you might skim over it and not do it. So sometimes some kids tick that they've got that mark, and that will help you not miss that question. Okay, I think that happened a lot. A lot of kids missed it. The number of days which rainfall was recorded. Oh, that's a bit easy. Sorry. The number of which no rainfall was recorded, 0 millimetres, that means. So that we did that before, 16. The percentage of days of which the rainfall exceeded 12 millimetres. So there's 12. This one's more. So 1, 2, there was 3 out of how many? 16? Oh, sorry, not 16. What was it? Yeah, that's a nice easy number, times 100, but you guys could do that surely. 10%? Yes? So that's where some people, if you're a bit quicker, you'll save time. And what have they got us doing down here? Use the grid to construct a histogram. So I'll draw that up now, but you guys know how to do a histogram. I'll do it in a minute. All right, cool. There's the histogram.